To quote Bill Bryson from his book, A Short History of Nearly Everything, it is a slightly arresting notion that if you were to pick yourself apart with tweezers, one atom at a time, you would produce a mound of fine atomic dust, none of which had ever been alive, but all of which had once been you. 98% of our universe is made up of only two types of atoms, hydrogen and helium. That's 98% of an estimated roughly 10 to the 80th power. Of all these atoms, 7 octillion of them, or 7 times 10 to the 27th power, make up the average person. An angstrom is a unit of measurement used only to measure incredibly small things, such as chemical bond lengths and light wavelengths. An angstrom is equal to 0.1 or a tenth of a nanometer, which is already 1/1000th of a meter. An atom is 1 to 5 angstroms in width, or in other words, 1 to 5 billionths of a meter. A human hair is 500,000 to 1 million angstroms in width. All of that to say, we are all made up of atoms that have one time or another been one thing or another. You are made up of atoms that were once stars, and some of the atoms and things you drink have come into contact with countless living creatures. All things are made up of them. Atoms, basically, are a combination of protons and neutrons at the center, forming something called the nucleus. There's a lot of empty space in an atom, but also electrons that move around the nucleus. Protons are positively electrically charged, while neutrons are neutrally charged. Those two are the ones existing in the nucleus, while electrons, which are negatively charged, exist around the nucleus because their negative charge is attracted to that positive charge. From what I understand, electrons don't actually move or orbit necessarily. They exist in a sort of wave function that is incalculable, and we use orbitals to predict a three-dimensional location of where an electron should theoretically be, which may be partially or wholly wrong. I'm just a guy, you can't believe everything here on the internet. Electrons also exist in layers away from the center of the atom, and these electrons reside anywhere in between those, depending on the energy level. Electrons with a higher level of energy exist farther away from the nucleus. One thing I do find very interesting is that while we consider atoms the building block of the cosmos, which they are, there are things even smaller still. Protons and neutrons are called hadrons, which are made up of quarks held together by a gluon field. Quarks are a standard particle, meaning they cannot be broken down any further to our knowledge. Electrons, however, are made up of leptons, which are similarly standard particles. What you would call a regular atom or a stable atom is neutrally charged, meaning that it has an equal amount of protons and electrons. This number of protons essentially decides the chemical makeup of the atom and where it lands on the periodic table of elements. To momentarily interrupt that train of thought, I want to add that through the gaining of an electron, an atom can become a positive ion or a cation, and through the losing of an electron, it becomes an anion. This is all important because these atoms, cations and anions, make up the periodic table of elements, and those elements are what create what we see and feel and smell every day. As stated, the number on the periodic table corresponds with the number of protons. There are 118 of them, 94 natural and 24 synthetic. Two terms that need to be understood are molecules and compounds. A molecule is two or more atoms bonded together. A compound is two or more different atoms combined together. So all compounds are molecules, but not all molecules are compounds. Water, for example, is a compound, and thusly a molecule, 2 hydrogen atoms and 1 oxygen atom. Gold or titanium, for example, which are chemical elements and appear on the periodic table of elements, are not comprised of molecules, but just of gold or titanium atoms. Things like nitrogen, or N2, are comprised of molecules consisting of 2 nitrogen atoms bonded. These molecules or compounds can be held together by a number of different things, such as covalent, ionic, and metallic bonds. Covalent bonds are a type of chemical bond that happen when 2 nonmetal atoms share pairs of valence electrons. Valence electrons are electrons on the outermost shell of an atom. They do this to achieve stability through filling their outer shells. An ionic bond is an electrostatic attraction between oppositely charged ions in a chemical compound. This primarily happens between a metal and non-metal atom. Instead of sharing pairs of electrons, a valence electron is permanently transferred to another atom. The one losing it becomes positively charged, and the one gaining becomes negatively charged. And something created of atoms through this, the negative atoms and positive atoms surround one another in a balanced manner, creating a hard substance. Metallic bonds, as you may have guessed, happen between metal atoms. Both metallic atoms and a metallic bond are positively charged. The interesting thing about metallic bonds is that it happens when these positively charged cations are densely packed and overlap. This allows the valence electrons to hop from atom to atom. Metallic bonds, as their name suggests, are usually hard and have very high melting points due to that. Thank you for making it this far in the video. As I said earlier, I'm just a guy on the internet. If anything is wrong in this, please let me know. I don't have any formal education on the subject. I'm just interested, and I just want to make a video. I also have a video planned on the history of the finding of the atom. Not necessarily the finding of the atom, but the discovery. I've been Ryan from CamelSync. Thank you for hanging out and learning with me.